We are awed by the grandeur and mystery of whales as they move through the ocean. Off the west coast of the U.S., the thrill of spotting a whale is becoming more common. Many species are recovering from near extinction. Some populations have yet to rebound and are still endangered. That's the case with blue whales, the largest animals on Earth. Now, scientists are using NASA Earth observations to overcome a major obstacle to protecting these whales, predicting where they'll be. NOAA's Monica DeAngelis helps manage the protection of whales under the Marine Mammal Protection and Endangered Species Acts.
The biggest threat to whale populations now is still humans. We've got vessel collisions, climate change, habitat loss or destruction, entanglement in any kind of gear, marine debris or fishing gear, anything that's out in the ocean.
My members, the ocean carriers that transit these waters, take this issue very seriously. Nobody wants to hit a whale. It's just one of those things that no mariner wants to be a part of.
One of the questions we're constantly asked from a management perspective is, where are the whales?
The whale swims underwater most of the time, and the ships don't have a sensor that they can see it. When the whale does come up to surface and breathe, that's for a very short period of time, and on these huge ships, it's hard for the watch officers to actually see the whale during that short period of time that it's breathing.
We felt that it was our responsibility as the experts on whales to tell them where the whales are.
Scientist Helen Bailey and her team partnered with NOAA's DeAngelis to tackle this challenge through a project called Whale Watch.
There are a number of products that are going to come out of this, but one of the most innovative is a near real-time tool that will use the latest satellite environmental data to predict the occurrence of whales off the U.S. West Coast.
The species of whale that Whale Watch will cover are blue, fin, humpback, and gray whales.
The whales were tracked using our Argos satellite telemetry. So a tag is put on the whale, and then a signal transmits up to a satellite whenever the whale is at the surface, which enables you to calculate the positions. We have tracking data from 1993 to 2009. We are combining the satellite telemetry data for the whales with satellite-derived environmental data to understand not just where are the whales going, but why are they going there. We call this the habitat model, understanding what is their required habitat, and then we can predict where the whales are going to go based on the environment. The environmental information comes from a number of satellites. For example, sea surface temperature and chlorophyll concentration we're getting from MODIS on Aqua, and then the JSON series of satellites for sea surface height. When we correlated the environmental data and the whale data, we found that the most important variables were sea surface temperature, which helped to explain their seasonal migration, the chlorophyll concentration, which was related to the abundance of food, and then also the ocean winds that explained the upwelling, which triggered that availability of food for the whales. The final one that was important was the slope of the seabed. We tend to see krill aggregate on that slope, and that seemed to be where the blue whales were too. We have that process automated so that on the website it will automatically download the latest sea surface temperature, chlorophyll concentration, and winds information, put it into the model, and then output this prediction map that is much easier for managers and other marine users to interpret. We will have the Whale Watch products on a publicly available NOAA website, so it should be relatively easy for them to find and access.
We're going to be getting information that we didn't have before, which is this ability to predict in near real time where we think animals might be.
That at least gives us that important point on the graph of where the whales are. We can then compare that to where the ships are going and see what adjustments can be made.
The Navy, the Coast Guard, shipping industry, fishermen, and researchers actually are very interested in seeing this come to fruition because they want to be able to take a look and use this for their own reasons.
In the same way that the ships are very conscious about the weather, they're very conscious about the whales, and if they know where the whales are, they can avoid them.
The bottom line is this is the best available science. We are now able to use that information to give whales a voice so that humans can change their behavior to reduce the threat to whales.